Hello everyone, welcome to another video. All right, so today we have another very nice question, about what we call the magnetic field. Okay, and this is a question about what we call the Lorentz force. That's the Lorentz equation. Now the question reads: a positive charge Q equals to 3.20 times 10 raised to the power of 9 coulombs. Okay, moves with a velocity v equals to this. Okay, that's 2I plus 3j minus k meters per second through a region where both uniform magnetic field and a uniform electric field exist. The force experienced by a moving charge which exists in the region of both electric field and magnetic field is what we call the Lorentz force. Okay, so the equation, that is the force formula, okay, is what we call the Lorentz what equation. So now let's set up the equation. So like I said, using Lorentz equation, we have Lorentz force, that is the force, the total force or the resultant force will be the what? The sum of the electric force and the what? The magnetic force. Okay, now the electric force is the product of electric charge and the what? Electric field intensity. Okay, then we know that the magnetic force is the product of electric charge, okay, and the cross product of the velocity vector and the magnetic field vector. All right, so we're using the equation, the Lorentz equation will now be F equals to QE, okay, plus QVB. Okay, so that this will be Q parenthesis E plus V, then that is cross product of V and what? And B. Okay, so that this will be F equals to, now the charge we're giving, remember, we're giving Q to be 3.20 times 10 raised to the power of -9 coulombs, and then we are giving the what? The velocity vector to be 2I, okay, plus 3j minus k, and this is in what? Meters per second. Then we're also giving the magnetic field vector. The magnetic field vector is 2I, okay, plus 4j, then plus k. The unit is what? Is the Tesla. Also, we are giving the what? The electric field vector. The electric field vector is given to be 4I negative j minus 2k, and this is in what? In volts per meters. So we are going to plug in this value, okay, into this what? Equation. So we have 3.20 times 10 raised to the power of -9, okay, open parenthesis. The electric field vector is 4I minus j, then minus 2k, okay, then added to the cross product of the velocity vector, which is 2I, okay, plus 3j minus k, okay, multiply by, that is cross product, okay, 2I plus 4j plus k. Now close parenthesis. Now, so in this case, we need to first find the what? The cross product of V and B. Okay, when we know the cross product of V and B, the cross product of V and B can be determined using what we call the right hand rule. When we have to hold open our right hand, hold open your right hand, okay, with the thumb finger pointing in the direction of the first named vector, and the fingers of the right hand, okay, point in the direction of the second named vector. Okay, then the palm of the fingers of the right hand will now represent what we call the resultant vector. Okay, that means a single vector will replace the product of these two vectors, and that single vector which will replace the product of V and B, both in magnitude and direction, is what we call the what? The resultant vector. And the resultant vector is the one which will be represented by the third line, okay, representing the line which is directed, okay, which is directed out of the palm of the fingers of the what? right hand. So let's get the cross product. Okay, now we have cross product, cross product, cross product of V and B. That will be cross product of V and B. So that means we need to find the what, the determinant. So we have I, the unit vectors are ijk. Okay, so for V, okay, it is 2, 3, then minus 1. Then for B, it is 2, 4, and then 1. Okay, so now we want to get the third vector, which will replace the product of V and B, and that is a resultant vector. So in this case, the cross product, okay, the cross product will be equals to, so we have I, 3 times 1, that will be 3. 4, this will be plus 4, okay, this will be plus 4, okay, this will be plus 4, then negative I brackets, this will be 2 plus 2, then plus k brackets 2 times 4, that will be 8, minus 6. That is when we use what we call diagonal multiplication. Okay, that is 2 times 4. Now for this, when it is j, we do 1 times 2, then 2 times negative 1, that will be 2 plus 2. Okay, then also for k, that will be 4 times 2, that's 8, then 2 times 3, that's 6, using diagonal multiplication, so that the cross product can be, this will be 7i negative 4j, okay, plus 2k. Okay, so this is the cross product of V and B. So we're going to what, replace this product with this. So this is the resultant vector. So now the first equation will now be 3.20 times 10 raised to the power of negative 9, open parenthesis, 4i, okay, minus j minus 2k, okay, then plus this vector. So that will be 7i minus 4j plus 2k. Okay, so close parenthesis. So let's add the vectors, okay, in terms of their unit. So we have 4i plus 7i, that will be 11i. So the vector force will be 3.20 times 10 raised to the power of negative 9. So 4i plus 7i, that will be 11i, minus j plus minus 4j, that will be negative 5j. Okay, now negative 2k, then plus 2k, that will be 0. So this is, so we can still multiply. Remember, the unit is in what? Newton. So that F will be equals to 3.2, okay, multiplied by 11, okay, minus 3.20 multiplied by 5, okay, multiply by 5, then that will be j, close parenthesis, then multiply by 10 raised to the power of negative 9, then Newton. Okay, so what is 3.2 multiplied by 11? 3.2 multiplied by 11, that will be 35.2. That is 35.2. So we have F equals to 35.2i. Now we also have 3.2 multiplied by 5, that will be 16. So we have 16j. Okay, then times 10 raised to the power of negative 9 Newton. Now, so this is the what? The total force on the moving charge, okay, in unit vector notation. This is the total force on the moving charge in unit vector notation. Okay, and that's question A. Now, secondly, we have what angle does the force make with the positive x-axis? So, okay, so we can say let theta equals to angle which F makes with the positive x-axis. Okay, so to be able to calculate the angle it makes with the positive x-axis, that means the force, okay, that's horizontal component of force, that will be F of x equals to F cos theta. So this f of x will now be equals to the magnitude of the force. Okay, that's the force. Okay, yeah, this force, that is the magnitude of the total force. Okay, then in the I direction, because this is now when we take 35.2 times 10 raised to the power of minus 9, I, that is in the I direction. So I is the unit vector along the positive x-axis. Okay, so we're going to use this. So let's find the magnitude of f, which is this. So we need to find the magnitude of this. So it will be we need to find the magnitude of, so that'll be the square root of 35.2. Okay, 35.2. Okay, 35.2. 35.2 times 10 raised to the power of minus 9. Okay, raised to the power of minus 9. I raised to the power of dash. Then I raised to the power of 2. Okay, plus 16 times 10 raised to the power of negative 9. Okay, j also raised to the power of what? Raised to the power of 2. Okay, so 3.35.2, okay, raised to the power of 2. Raised to the power of 2. That will be 129. So we have the magnitude of f. This will be 1239.04. Don't forget that this will be squared as well. So that will be 10 raised to the power of minus 18. This will also be 10 raised to the power of minus 18. So let me get 16 squared. What is 16 raised to the power of 2? That will be 256. So that will be added to 256. Okay, then multiply by 10 raised to the power of negative 9. Okay, it will be negative 9 because, when we square this, 2 times minus 9, that will be minus 18. So this will also be minus 18. So 10 raised to the power of negative 18 will be common. So we factor it out. And the square root of 10 to the power of negative 18 will be what? 10 to the power of negative 9. So, and that's what we have here. So now, when we add 256 to 1239.04, okay, that would be 149. So we have the magnitude of f to be 1495.04. Okay, 1495.04. So let's get the square root of 1495.04, and that will be 38.67. Okay, so 38.67. Then we still have 10 raised to the power of negative 9 Newton. So the magnitude will be 38.67 times 10 raised to the power of negative 19. Now, why it is important to find the magnitude is because, remember, we want to calculate the angle the vector force or the force vector makes with the what? The positive x-axis. Okay, so which means we need to find we need to get rid of the unit vector notations, the ijk. Okay, so, and to get rid of the ijk, remember dot product. The dot product of that's I dot I, that will be 1. J dot j, that will be what? 1. K dot k, that will be what? 1 as well. Okay, unlike when we are doing cross product. For cross product, it will be high cross product of I and I will be 0. Okay, like that. So then j and j will be what? 0. All right, so let's continue from here. So we have this. Now remember that I said to be able to calculate theta. Okay, to be able to calculate theta. Now we're going to set, we know that for the horizontal component, so we have, this is the angle, okay, this is the force, this force. So we have the resultant vector, okay, which is 38.67 times 10 raised to the power of negative 9 Newton. Okay, then we now have the f, we have f of x, which is the force along the positive x-axis. That is the force on the moving charge along the positive x-axis. Okay, and we have also along the y-axis as well. So, but in this case, by principle of resolution, we know that f of x will be what? F cos theta. Okay, then f of y will be equals to f sine theta. So this is the y-axis, then this is the what? X-axis. Okay, so because the question reads, what force does the vector force or the force vector makes with the positive x-axis? So that's why we have to do f of x, which is equals to this force, okay, cos theta, and that will be equals to this f of x, since it is along x-axis, and this is the force along x-axis in what we calculated here. I is the unit vector along x-axis, that's positive x-axis. So we're going to multiply this value by 10 raised to the power of minus 9. Also, we have this to be 10, so which means we're going to have cos theta to be equals to, okay, to be equals to f along x-axis, okay, divided by the what? The magnitude of the what? The force vector, okay, the magnitude of the force vector, so that theta will be the inverse cos of fx, okay, over the what? The magnitude of f. So now let's plug in the values. So we have here that theta is equals to the inverse cos of so this value, okay, 35.2 multiplied by 10 raised to the power of negative 9 divided by 38.67 multiplied by 10 raised to the power of negative 9. Okay, so when this divide this, so we'll be left with, we have theta equals to inverse cos of 35.2 over what? 38.67. So we have 35.2 divided by 38.67. That will be 0. So this will be, theta will be equals to the inverse cos of 0.9103. Yeah. So we have, what is the cos inverse of 0.9103? That will be 24. So theta will be equals to 24.45. And this is the angle, okay, the force vector makes with the positive x-axis. The noblest pleasure is the joy of understanding. Bye-bye.